Hello and welcome to day 24 of Advent of Code, the penultimate day. Let's jump in and solve it. Okay, so today's problem is the input is a series of lines to flip hexagon tiles, and they look like this. And lines are composed of directions, either east, west, northeast, northwest, southeast, or southwest, so there's variable length in these, so you can't really do any clever slicing, unfortunately. And the way we're going to be processing this tile, or these instructions, is line by line. And you start at the origin, you follow these movement instructions, and at the end, you flip the tile that's at that position in the line. So, in this case, we would do southeast, then northwest, then northeast, etc., etc. Now, the tricky part that I found for this problem, or what I got a little bit tripped up on, is how to represent these coordinates. And I came up with a little solution that I found was pretty easy to deal with. So we're dealing with hexagons. And if we take one of these, let's make our axes here. We'll make them gray, I guess. I want the line tool. Line tool. So let's say these are our axes, and this is, 0, 0, where we're starting. And if we make another hexagon, oh dang it, I should have made the axes first. Let me do the axes first. And then we'll put a hexagon into place. That'll be the easy way to do this. So now if we go to hexagon and we do that as black, and then we can move this around. Cool. There's our hexagon at 0, 0. So what I thought about for this problem is we have to imagine that we have a grid of these hexagons, so something like this. Let's actually just do all the ones that are around this central one, and then we'll show you how I managed coordinates. So we got 6 of these here. We know that we're starting at 0, 0. 0, 0. And the way that I represented this is by using an arbitrary unit for each of the positions here. So in order to move east, what I did was I moved just 2 units to the left and represented that as the center here. So we're starting from here, and we're moving to here. And so I represented that as just, plus 2x. Plus 2x. And for west, I represented that as minus 2x. So minus 2x. I shouldn't do this as we should do this as text. So east is plus 2x and west is minus 2x. Let me draw that here. And then I needed some way to go to this one here that would also work if we went northwest and then southwest to get to here. And so what I did was plus 2 and minus 1, and then minus 2 minus 1 to get those 2 directions. So for any of the north, let's do northeast. Northeast would be plus 1x and plus 2y, for instance. And that was how I managed my coordinates. So I just represented them as the centers of the hexagons. And I mean, my hexagons weren't perfectly the right size, but using this, offset here worked correctly for me, and I was able to map out a grid of hexagons. There's a bunch of other ways to represent hexagons. I did some research after I solved and found that no one else did it this way. They did there's a cube representation, or there's one where you use all of the directions but you ignore 2 of them, so you only have 6 directions that you can move from an individual XY coordinate. But this worked for me, so this is what I did. And it turns out it doesn't matter what coordinate system you use to manage these as long as you are consistent. So this is what I did, and we're not going to split up the input parsing for this one, mostly because these are variable width, and parsing it out, I mean, it might make it slightly easier to understand, but I don't think it actually improved the readability of this problem. But anyway, let's do for line in s.splitLines. So we're going to loop over each of the line. We need to represent the colors of the tiles, and for part 1, they all start white, and after executing the instructions, we have to figure out how many are black, and each of these lines is going to mark one tile. It's going to flip one tile. It's not necessarily going to mark it as black, it's going to flip it. And so when I saw this, I decided to represent the tiles as a set where I'm just recording the black tiles, because we don't really, you can just assume every other tile is white, and so we only care about the black tiles. So I had a black tiles equals a set, and I was going to populate this set as we went along. Okay, For line and s dot split line. So then we need to process this line. The way I process this line is I said that I equals 0, and then while I is less than the length of the line, I'm basically going to loop over the positions in the line. And so then I need to check each of the directions. I just did this manually. So if line dot starts with east at position I, then we know we're doing east, and so we can do, oh right, we need, you know, x equals y equals 0 for our position. If we're moving east, we can do x plus equals 2, and since east has a length of 1, we need to increase I by 1. LF line that starts with west, then x minus equals 2, minus equals 2, and I plus equals 1. LF line that starts with northeast. And of course you could do this with like a loop that's a little less verbose. I guess we could do that as a loop. Let's do it as a loop. Sure, why not? For direction dx, dy in, and then we'll write out all of our directions, east. Actually, it's probably worth it to write out the directions anyway. Directions equals east, which is going to be 2 and 0. We have west, which is -2, 0. We have northeast, which is 1 and 2. This is dx and dy. Northwest, which is -1 and 2. Southeast, so has 3. Southeast is going to be 1 and -2. And southwest is going to be -1, -2. So then we have our directions there, and then we can do for ds, dx, dy in directions. If line dot starts with ds at I, then we can do x plus equals dx and y plus equals dy. And I plus equals len of ds. I like this a lot better. This is way nicer than what I had. And then we can break out of this loop. And just for sanity's sake, if we never match any of the directions here, there's probably a problem. So I'm going to do raise assertion error line I colon. That way we know whether there's a problem here. Okay, but this should move this x and y into the right position, and then finally we need to mark that position in our set of black tiles. And the way I originally wrote this was to say, like, if x, y in black tiles, then black tiles dot discard x, y, otherwise black tiles dot add x, y. So basically this is a toggle here. It turns out there's a clever way to do this that I didn't, I actually learned while I was writing this out. If you have a set here, this is a set, and we want to toggle whether 3 is contained in this set, you can use symmetric difference update to toggle things. So you can see we first did a symmetric difference, and since 3 was not in either of these, then it got added. And in this case, it was in there, and so it got removed. And so this is kind of a neat little trick here. So we'll write it with the neat trick here. Black tiles, symmetric difference update, a set containing x, y. And so that should solve part 1. Basically, process all the lines, do that, and then return len of black tiles at the very end. That should do part 1. Let's make sure that is true. Python part 1. And we get 10, which is the value that we expect there. Cool. That's part 1. Part 2 is yet another game of life problem. So let us copy part 1 to part 2. Part 1.py, part 2.py. And this is a game of life problem. So I'm going to use the same strategy that I used in previous problems to do game of life problems. One clarification that was super unclear from the problem description, and I actually wasted a ton of time on this. Part 2, you don't reapply these rules ever again. So after the first apply, you just run the puzzle after there. So I was applying these in each inner loop, which is not needed. But we're going to use the same strategy that I've used in previous game of life problems, which is to mark all of the counts of things and then sweep the items afterwards. So we're gonna do that again. So import collections, although you could do it by just manually looping around. That would work here as well. And for underscore in range 100, so we're gonna run 100 loops of this, and we need to count things. Fortunately, we already have a list of directions here, so that's kind of nice. Let's see, counts equals collections dot counter, and we're gonna do for x, y in black tiles. So we're marking how many black tiles are around things, because we only care about that. If it's a black tile and 0 or greater than 2 around it are black, it becomes white. If it's a white tile and 2 around it are black, it becomes black. So for x, y in black tiles, and for underscore dx, dy in directions, count x plus dx and y plus dy plus equals 1. So this will mark the counts there. Then we need to do this. If it's a black tile and 0 or greater than 2 are black, it becomes white. So if, we need to loop over all black tiles. So for x, y, and black tiles, if counts x, y is equal to 0 or counts x, y is greater than 2, then we discard from black tiles. Now, of course, we're looping over black tiles, so let's do a toDiscard set. toDiscard equals a set. toDiscard dot add xy. So this is, removing those from the black tiles. Then we also do, if it's a white tile and 2 around it are black, then go to black. So I'm going to loop over our counts this time. For x, y counts in counts.items. If count is equal to 2 and x, y not in black tiles. So if it's 2 and white, then black tiles dot add x, y. And then, we forgot to do this discard here, so we gotta do that as well. Black tiles dot discard to discard. Actually, let's move this up here. I think this doesn't matter what order we do this in. I forget. But yeah, I think that implements our game of life. Mark here and then sweep here. And so at the end, we should figure out how many black tiles there are. My solution was a little bit slow here. Oh, that's not the right number. Should have been 2208. Let's try putting this down here. Let's see if that's what does it here. Uh-oh. Why is that the wrong number? All right, let me look at my solution. Day 24 part 2 dot pi. So again, we have these same direction sets here. And this is my solution with this big old long for loop. Yeah, so then counter dx dy. This looks the same. This looks the same. Although I did this slightly different. This code looks basically the same. Let's try and do it exactly the same. To add equals set. Oh, discard. This should be minus equals. That's what it is. I'm surprised I didn't get a type error there. That's the problem. That should be the problem. Oops. Python 3 part 2. We get 2208. Okay, cool. Little transposition there. So I need a difference update, which is minus equals. Discard removes a single item from a set. But anyway, that's our day 24 part 2. I guess I'll see you for the next day, the very final day, day 25. Have a good one. Bye.